All right, welcome back, ECU warriors. Today's explainer is a big one. We are demystifying module replacement and ECU programming, all so you can finally stop relying on the dealer. Look, if you've ever stared at a totally dead module in your bay and wondered if installing a brand new ECU truly requires sending the car away, or if you can handle a used ECU replacement right there in your shop, well, you are definitely in the right place. We're going to dive deep into the exact workflows, the automotive diagnostics, and the tools that make independent programming an everyday reality. So here is our roadmap for today. We're going to cover cloning versus OEM programming, then immobilizers and component protection, followed by coding and calibrations. After that, we'll talk about choosing your diagnostics, walk through a real-world workflow, and wrap up with independent workshop solutions. Let's just jump right in. Section 1. Cloning versus OEM programming. First off, we really need to understand the fundamental difference between bringing a dead module back to life and initializing a brand new one. Okay, so the crucial point here is that cloning is a highly cost-effective adaptation for used parts, while OEM programming is the gold standard for blank modules. Think of cloning as basically a brain transplant. You're physically or virtually moving the soul of the original unit, which is the EEPROM and flash data, right into a compatible used replacement. OEM programming, on the flip side, is like giving a brand new blank module its factory-fresh identity by downloading the build directly from mothership servers like ISTA, ODIS, or Xentry. Now, what's really interesting and honestly absolutely crucial about this slide is the strict dividing line we have to draw. Safety-critical systems must always utilize OEM tools. Literally zero shortcuts here. Cloning is fantastic for getting a customer's climate control or body control module back online quickly and cheaply. But look at systems like airbags, storing crash data, ABS units with unique vehicle calibrations and ADAS sensors? No way. Those require precise, factory-level OEM programming to ensure passenger safety. Moving on to Section 2, Immobilizers and Component Protection. Let's see how this builds into overcoming automotive security roadblocks. So, Component Protection Systems, or CP. VAG basically designed this to stop the black market for stolen parts. Though, a lot of techs jokingly call it dealer profit protection. Generation 1 hit the Audi A8s in the mid-2000s, and we're now well into Generation 3. Usually, removing CP requires an ODIS online account to adopt the module. But interestingly enough, specific aftermarket licenses like AVDI's VN017 can actually manage this by reading the Lear gateway directly via OBD, completely bypassing the need for donor gateway. And this brilliantly illustrates the hardware side of security. Take the Ford PATS module, for example. Erasing keys just isn't enough if the PATS module doesn't recognize the new powertrain control module. If your locksmith only wipes the keys, the vehicle is still only going to start with the original computer. Immobilizer synchronization is just as vital as turning the wrenches to install the hardware. To get those keys programmed properly after a PCM swap, you have to perform a parameter reset. You cycle the key, enter security access, which, usually makes you sit there for 10 agonizing minutes, select your reset, and then absolutely remember step 4, the Keep Alive Memory or CAM reset. This returns the PCM to its default setting and clears out adaptive learning. Only after this reset will the module actually accept the new computer, allowing you to program your 2 keys. All right, Section 3, Coding, Injectors to Calibrations. Beyond just security, replacing a module means telling the vehicle exactly what new hardware is installed. Let's talk injector coding. Whether Bosch calls it an IMA, Delphi a C2I, or Denso a QR code, it's essentially the injector's unique DNA. Because it's literally impossible to manufacture identical injectors, these codes detail the tiny variations in flow rates and component weight. We are talking about pressures exceeding 2,000 bar. If you fail to program these calibration codes, the ECU is basically flying blind and just guessing the fuel delivery. And a guessing ECU, that leads to excessive smoke, crazy engine knock, or just a flat-out no-start condition. Check out this specific detail from Harwood. It proves exactly why recoding isn't just a polite suggestion, it's a hard requirement for the engine to physically run. If that learn voltage code, which is often just a single letter or a 3-digit number, is outside a predefined band, the vehicle will simply refuse to start. Period. Okay, Section 4, Choosing your diagnostic tools. Let's look at the hardware making this independent work possible. So, let's map out the J2534 pass-through application architecture. This was a real game changer. J2534 is an SAE and EPA standard application programming interface.
It was originally put into laws so independent aftermarket shops could flash emissions control systems without having to shell out thousands for every single dealer-specific hardware interface. And today, many manufacturers actually allow full vehicle reprogramming right through this standard.
While tools vary wildly in their capabilities, this objective data shows that your choice of scanner dictates your success rate with specific manufacturer hurdles. For instance, the Autel IM608 is a beast for VAG IMMO 5 BCM2 data reading and BMW ISN reading in bench mode. Meanwhile, the Launch X431 really shines with Mercedes, supporting reading and writing for 18 different ECM types. Honestly, knowing the strengths and blind spots of your specific aftermarket tool is half the battle. All right, Section 5, Real-World Programming Workflow. Now let's tie all of this theory together with a practical GM SPS2 module replacement workflow. Before you even touch the OBD port, you gotta have your environment locked down. You need stable internet, a genuine J2534 device, and your OEM service info. But most importantly, and I cannot stress this enough, you absolutely must use a professional battery maintainer. Actually, scratch that. A standard battery charger doesn't just send dirty voltage, it will literally crash your module. Imagine breaking a unit during a 2-hour radio flash just because your voltage dipped. Just don't do it. So once you're inside GM's TechLine Connect, you hit SPS2 and choose Replace and Program for your specific module, let's say a K38 auxiliary chassis control module. You verify your calibrations and flash the software. But look, always check your service info first. If you miss step 4, the setup and configuration, like an Immobilizer learn or a brake pressure sensor adaptation, you're going to be stuck with an unconfigured module code, even if the flash itself was 100% successful. And that brings us to step 5, clearing codes. Because when you disconnect batteries, unplug sensors, or flash modules, you generate a massive amount of communication codes. This is what we call a cyber fingerprint. It's basically a virtual roadmap of your repair. You absolutely must erase this shop-generated cyber fingerprint from every module on the network. If you don't, you're going to leave false communication codes that will totally confuse the system or the next technician who works on that car. Finally, Section 6, Independent Workshop Solutions. Let's talk about how to tackle jobs when your local hardware just isn't quite enough. Look, you don't always have to tow the car to the dealer. If you lack a specific subscription, remote programming services at companies like ArmHacks can connect directly to your laptop and J2534 device using TeamViewer. They can perform online coding or Immobilizer resets while the car sits right in your bay. It is a highly effective dealer programming alternative that lets you keep the customer and the profit in-house. Plus, registries like NASTF in the US and CERMI in Europe are specifically designed to accredit independent shops, granting you secure access to the Immobilizer and security data that manufacturers usually try to lock down. So, thinking about the tools and workflows we've covered today, with the right pass-through device, reliable service data, and access to remote experts, the independent shop has honestly never been more empowered. So I'll leave you with this question. As J2534 protocols evolve and remote coding expands, are dealer-only repairs becoming a myth of the past? Thanks for hanging out for this explainer, ECU warriors. Keep mastering those diagnostics, and we'll see you in the next breakdown.